In this video, I want to talk about doing the derivative of the sine function. So, as with any derivative that we don't have a current rule for, our only discourse, our only recourse, is to go and invoke the limit definition. Remember, the limit is f of x plus h minus f of x over h. All that is h goes to 0. So we plug that into the sine function. So we get limit as h goes to 0 of sine x plus h minus sine x over h. Now what I need you to recall here is that from trig, you had an angle sum identity that said sine of x plus h is equal to sine x cosine h plus cosine x sine h. Okay, so we have this identity from trig that you need to remember here. This sine x plus h equals sine x cosine h plus cosine x sine h. And that's what we're going to do. We're going to go in and we're going to replace our sine x plus h with this expression here, and then do a little bit of regrouping and see what we get. So just going in, replacing sine x plus h with what it's equal to, sine x cosine h plus cosine x sine h. And now we're going to do a little bit of rearranging here. So first notice this sine x cosine h and sine x both have a sine in them. So we're going to put those together, right, and factor out a sine h. So I have limit as h goes to 0 of sine x times the quantity cosine h minus 1. That's all going to be over h. I'm going to break that apart into one fraction plus the remaining stuff, cosine x times sine h all over h. Now, as we're doing this limit here, the sine x doesn't depend on h, so it's like a constant as far as h is concerned. Same thing with the cosine x. It's like a constant as far as the h is concerned. So those things can come out. But as we're doing that, recall we have two limits that we learned previously, sine h over h, which we did with the sandwich theorem. That's equal to 1. And then by simplifying, by doing some manipulation of 1 minus cosine h over h, or cosine h minus 1 over h, we can show that that limit, both those limits, are 0. So now we go ahead and we do a little bit of rewriting. Sine x can be, again, pulled out. So limit as h goes to 0 of cosine h minus 1 over h plus cosine x can be pulled out of the second one there. And we're left with sine h over h, all in terms of limits here. Actually, there's a little bit of a typo here. Okay, so we have our little typo. It should have been cosine x times the limit as h goes to 0 of sine h over h. Apologize for that little typing mistake there, or writing mistake. And so at this point, we bring in our two limits. This cosine h, we know that's going to become 0. And the other one here, sine h over h, we know that that's just going to become 1. And so we can write that out, sine x times 0 plus cosine x times 1. And then finally, we get just cosine x. And so it turns out the derivative of the sine function, is actually just the cosine function, which is really kind of quite remarkable that they work that way. Kind of a little surprising that it comes out that way. You're going to work out the derivative of cosine, which is referred to as a turn-in problem on the notes. Okay, so but now we have the derivative of sine is cosine.